Okay. So, what's the correct order, Kennedy?
2x to the fifth plus x minus x squared minus plus 9.
Very good.
Nice.
Okay, so what's the degree? Sydney? 5, right? 5th degree. Identifying the degree and number of terms we know is 4. What's the name of it?
Linear polynomial.
Go ahead.
Linear polynomial with 4 terms.
Not linear. What's the degree of 5? Quintic.
Oh,
All right. So a quintic polynomial with 4 terms, right? That's how he would name it. Okay. Question? Kennedy, you have a question? No. If it's got 2 or 3 terms or 1, you can say, instead of polynomial, you say monomial, binomial, or trinomial. But we go by the degree, all right? 0 degree, constant, 1st degree, linear, 2nd, quadratic, 3rd, cubic, 4th, quartic, and 5th, quintic. All right, this one, 4x cubed plus 23. What's the leading coefficient? 4. What's the degree? 3. 2 terms, name it. Cubic binomial, yeah, because there's only 2 terms, we've got a special name. But if you said cubic polynomial with 2 terms, I guess you're right. Okay, when it says this, subtract this from that, okay? This one comes first. You guys realize that, don't you? It's like this. You guys understand that? It's not in this order, it's this order. When it says subtract this from that. Yes, sir.
Would that minus sign distribute the variables? In the
Yes,
sheet?
it would. So, my first term of my answer would be negative 4x to the 5th, right? And then plus 3x to the 4th. They don't have any like terms I can add, subtract. No x cubes, no x squareds, x. So this is 10 minus negative 8, which would be 18, right? Plus 8x, right? And then negative 9 minus 2. So that would be the answer then. Okay? What page was that? 410?
Yes.
All right. We started at what number? 20. All right. Degree was 4 for 20. For 22, the degree was 13. Any questions? We just add up the exponents, right? Well, it's a monomial, single term. 24, negative 4x to the 4th, minus 6x plus 5 to the 7th. That, since that's a constant, okay, that's just a degree of 0. They're trying to trick you. If that had a 5x to the 7th, we would have put that first, right? So the leading coefficient was negative 4. The degree was 4. It had 3 terms. It's a quartic trinomial. We're doing even, right? Okay. 26, 2x to the 6th minus 4x to the 4th plus 3x squared minus 1 is the correct order. The degree is 6. We got 4 terms. 6, there's no special name for a 6th degree, so we just say 6th degree polynomial with 4 terms. I mean, we could say hexagon, like a hexagon.
I agree.
28, just subtract. And where's that answer? I'm hiding it from him. Oh, here it is. Negative x cubed plus x squared minus 6x plus 8. Number 30, 3y squared minus 2y minus 2. 32, you were supposed to graph, and what is it? Does it hit twice? Does it hit the x-axis twice? No? It's underneath the x-axis? Okay, so there's no real zeros then, right? 34, did that look like M or a W? A W, okay? So it had 4 real zeros. It crossed 4 times, right? What did it go? Down, it decreased, increased, decreased, increased, right? 36, standard form was 3x squared plus 8x minus 5. Leading coefficient was 3, degree was 2. 38 is negative x to the 4th plus x cubed plus x minus 1. Leading coefficient is negative 1, degree is 4. That's where we stopped, wasn't it? Okay. Questions on any of those? Pretty easy stuff, wasn't it? Some new terminology, but stuff you've already done, or you already did in Algebra 1, wasn't it? Wasn't it? Okay, today we're going to multiply these polynomials. Oh, that's yesterday's assignment, right? I don't want that one. I want this one. So we're going to multiply polynomials and do some binomial expansion. What's binomial again? 2 terms, right? All right, so we're going to use the distributive property and properties of exponents. So go ahead and do A for me, Mr. Zito.
4y to the 4th
Very good.
plus 12y squared.
Good. So we add the exponents. We have the same variable. We add the exponent. We just distributed there. Any issues there? Okay. Mr. Reynolds, you can do this one for us.
Oh, Scott.
I got faith in you. You said you don't, Scott? You don't have faith in yourself?
Not really.
Oh, come on, man. How many F's are there?
4.
There's 4, yeah. How many here?
1.
So how many total?
4.
1 and 4 is a total of 5, yeah. All right? How about this one?
Like the total?
You just multiply them.
4. Wait. Yeah. 3.
Yeah, 4 F's. What's numbers in front of this here?
1.
1. What's 1 times 2? Thanks. What's G times G? Very good. You're on a roll now.
Negative 3x.
F to the, oh, there you go. And G, don't forget there's 1 here. Yeah. And the last one. Good. Good. You got it now? Do we all have it? So we're just multiplying or distributing, and then we're adding the exponents for the variables that have the same letters, right? Multiply the coefficients, right? The coefficients are the numbers in front, right? Add the exponents, okay? Can we handle that part? You with me? Okay, so I don't need to do another set of those, do I? How about we get 2 and 3? A binomial times a trinomial. How many answers? How many terms? 6. Yes. Okay. So, x times x squared, x cubed. X times 4x, 4x squared. This got kind of fuzzy when I made it bigger. X times negative 3, all right? 2 times x squared, 2x squared, right? 2 times 4x, 8x. 2 times negative 3, negative 6. So there's the red ones, there's the blue ones. How many total terms are there? 6. That's what we expected, right? 2 terms times 3 terms, 6 total. But when we combine like terms, we don't always have that many terms. That's okay. So I like to do it like this because then, then I can just, do vertically addition. So I got an x cubed. 4x squared plus 2x squared is 6x squared. Negative 3x plus 8x is 5x. And then minus 6. So I have a cubic polynomial with 4 terms when I'm done. Okay? Yeah. Does that make sense? We can handle that. Sure we can. All right. So, Grace, talk me through this one, please.
What is the 2a and then 5 or minus 5 and then a squared
Good.
and then plus a to the third
Good.
and then negative 6 and plus 15 and then negative 3a.
Were we supposed to get 6 terms? Yes. Did we get all 6? Yes. Did you see what I did with the like terms?
Yes.
I just lined them up. Now, you don't have to do that like I'm doing if you don't want. You can just make it all one big long one. But I just kind of like to do that, then I know where my like terms are. So, Cade, what's the final answer? No B's in there.
No, I said it would be,
Oh, okay.
8 to the third
Good. Getting it in the right order.
minus 8a squared plus 17a minus 6.
Good. So let's put it in the right order when we're done. Highest exponent down to the lowest. We okay with that? Any questions? I know, I was just messing with you, honey. That's what you said. All right. Coli. Ceiling, let's go.
Y to the fourth. Y to the third, minus y to the third. Minus 3y squared. It would be negative 7y to the third. Negative or positive 7y squared. And negative, no, positive 21y. 5y squared,
That's positive, right?
yeah, minus 5y, minus 15.
Any questions on how we got all 9 of those? Great.
Why do you put the only one y like above?
Just because I didn't have it, I didn't have another Y, so I just, ones that are different than what I've already written, I just put it there. But you could have kept it there if you want. And then I could have put that negative 5y under it here. Yeah. But that's just, we okay so far? Okay, Alex, what's the answer?
12 to 4. Minus 8y to this. Plus 9y. Plus 16y.
Very good. Any questions? Multiplying polynomial is simple, isn't it? Just take your time. Okay? Add your exponents for your variables. Multiply your coefficients. And then combine like terms. Yes, Sam?
This might be like kind of a stupid question, but like, why don't you add the exponents for like? the-
When you're doing addition, you mean from here to here?
Yeah.
Okay. Well, our rules of exponents say when I multiply, you know, if I was well, let's just look at one here. I got y squared times y squared, right? Right, so this means this. Right? That's what that means. Okay? But, you know, when I do addition, like the 5y squared, and I do the 7y squared, okay, I'm doing addition, so I'm not, they have to be the same before I can add them, like apples or oranges or whatever, okay? So the first step, we're gonna add the exponents, but after that, they have to be the same to, you know, combine the like terms. All right? So multiplication a little different than this, right? That would be how many terms? 6 terms, right? That one? 9. Same stuff, right? Okay. Expanding a binomial. Okay, here's one way to do it. Okay? And you can't multiply all of these together at once. You can only do 2 at a time. All right? So we go a times a times 2b. I always put my variables in alphabetical order. 2b times a. Again, I just keep them alphabetical order. And 2b times 2b is 4b squared. Well, these are like terms, so I can make this a squared plus 4ab plus 4b squared. You okay with that? Any questions how I got to there? And then I have to take this answer. Yeah, I FOILed these, right. Then I take that answer times the third one. All right? So that's a squared times a, and a squared times 2b, and then 4ab times a is 4a squared b, and 4ab times 2b is 8ab squared. And then 4b squared times a is 4ab squared. And then 4b squared times 2b is 8b cubed. Right, there's 3 of them now. And then I combine my like terms to finish up. Why? Every time I do that. 2a squared b plus 4a squared, those are like terms, so I can actually add those, and then the a squared b doesn't change. That's what Sammy was asking. All right, that just stays. Just add your coefficients. 8 plus 4 is 12. ab squared, and then the 8b cubed. Look at the a's. I got 3 squared, or a cubed, a squared, a to the first, no a's. I got no b's, and I got 1b, 2b, and 3b. That's usually what happens. The one that comes first in the alphabet gets smaller by 1, and the one that comes second in the alphabet gets bigger by 1 each time you go through this. Okay? Now that's one way to do this. And this isn't bad when you got a 3, but what if you get like a 5 or a 6? Would you want to keep doing that? No, you wouldn't, okay? So we're going to use Pascal's triangle to do that same problem, okay? And here's how you make Pascal's triangle. All right, you start with a 1. Very top, you're making a triangle. And you're going to make 2 more 1s. Looks like a triangle, kind of, right? Each row starts with a 1 and ends with a 1. To get the numbers that we start filling in now, you add these 2 together. What's 1 plus 1? 2. Okay, and then this starts with a 1. What's 1 plus 2? What's 2 plus 1? And you always end with a 1. What's the next row, Olivia Carr?
1, 4, 4. Oh, sorry, 6, 4, another 1.
You guys see that? Olivia Wyndham, what's the next one?
5,
Well, start with a 1.
1, 5, 10, and 1. 5, 1, 5.
5, 1. Everyone understand how we made that?
What does it do?
What?
I'm confused. Like,
How's it go with this?
yeah,
Okay, I'll show you. Okay. So we all, any questions on how we got the numbers? You start with the 3 1s. Always start with a 1, and then you can start adding numbers above it. 1 plus 1 was a 2. End with a 1. Start with a 1. 1 plus 2 is 3. 2 plus 1 is 3. End with 1. Okay, we got that? All right. So this problem we just did was what? A plus 2b cubed, right? So I'm going to do the same problem using Pascal's triangle. Okay? Since my exponent is a 3, I'm going to use the row that has the 1, 3 in it. All right? If my exponent started with a 4, I'd use the row 1, 4. If my exponent was a 5, I'd use the row 1, 5. Okay? If it's bigger, I keep going until I get to that 1. Okay? You with me so far? Okay. So, here's what I do then. I take those 4 numbers, which is 1, 3, 3, 1, right? So I take a 1 and then I make 2 sets of parentheses after it. Always plus 3, 2 sets, plus 3, plus 1. All right, so that's how you start. Whatever the numbers were in the row you're using for Pascal's, you make 2 sets of parentheses right behind it. And always addition. Okay? In the first parenthesis is always the first term in the problem. What do you think goes in the second parenthesis? The second term, yeah, the 2b. All right, so far so good? All right. The first exponent is whatever the problem's exponent was. So this is a 3. And then you go down by 1s as you go. 2, 1, all the way to 0. The second one starts at 0 always and goes up by 1s. Questions? do it that way every time. So again, the 1, 3, 3, 1 came from where? Pascal's triangle numbers, right? And why did I use the 1, 3, 3, 1? Because my original problem had an exponent of 3. Okay? Once you write however many numbers you need, this one we only needed 4. We'll make 2 sets of parentheses after each one, and then the first term, because it's a binomial always, it's just going to be 2 terms when we do this. First term always goes in the front parenthesis, second term goes in the back. The first exponent is always whatever is the original problem for the first one, that's always 0 for the second one when you start. And this first one goes down by 1s, and the second one always goes up by 1. Okay, then I just find those 4 answers, and I'll have my answer to the problem. Now, what do we know about anything to the 0 power? Nope. Not 0. Not itself. 1, right? So, 2b to the zeros, a 1. A to the zeros, a 1. So, since it's a 1 and I'm multiplying, do I need to worry about it? No. So I usually do this. When I see those, I always cancel those 2 out. Not even worry about it. Because it's like multiplying by 1. It's not changing anything. Right? So what's 1 times a cubed? A cubed, right? We'll just go black. So that's the first term. Okay, what's 3 times 2 to the first? 6. A to what power? Second. B to what power? First. Do we need to put the 1? No, but if you want to, if that helps you, you can. What's 3 times 2 squared? What's 2 squared? 4 times 3. 12. A to the first, B to the second. I don't need to worry about that, right? Because it's 1 times something. What's 2 times 2 times 2? 8. B to the third. Is that the answer we got when we did it the other way? Guys, look at your paper. Those of you that wrote it down. Let's see. I want to go the other way. I'll move this up. Those match? They did, didn't they? Okay. If it's one like this, 3, it's not too bad doing it the way we did it. When it's, even 4 is not too bad. Because 4, all right, would be this, I did 2 of those. Well, these 2 over here would have been the same thing, right? So I could have done that, doubled it, and then done it like we've done, get our 9. But I think, once you learn Pascal's, I think it's real easy to just do it this way every time. Okay, what time we got? 10 after? You don't really have time to do another one, because it takes a little time. All right, you got questions on that at all? Okay? Okay. So if you want to do it the long way, you don't have to do it that way, but it shortens things up for you. There's Pascal's again, but I just did it. They've got some examples in here if you want to look. They did the same thing I did. See, it's to the 5th, so the 1, 5, 10, 10, 5, 1 was the row we would use to do that. What goes in the first parenthesis? X. What goes in the second? -4. When it's a minus, put the negative in the parenthesis. You can still put pluses in between, but what's going to happen We're just gonna start positive and then it'll alternate. Positive, negative, and keep going. Also, there's always one more term than it is variable. Exponent. So it's to the fifth power, there'll be 6 terms. You know, the one we just did was to the third power, we had 4 terms when we were done, right? That's always gonna be true. So 18 to 51 by 3s. Skip number 39. I think it's 10 problems. It's not too bad. Okay. Tomorrow, after we go over this homework, I'm going to give you the practice exam. All right. So the stuff we've gone over, today from yesterday and tomorrow from today, we'll have a few problems on the exam from this. But I won't actually give you a quiz before that. You'll just see a couple of them on the exam. Okay?
Those are next week, right? I got you.
Yeah, next Thursday and Friday is your exam for me. Yeah, it's during this period. And it's 30 problems. On Thursday, I'll give you 11 of them to do. That will be, like a normal test where you have to show all your work in that. And then on Friday will be 19 problems, and it's all multiple choice. Okay? And again, I'll let you know, but we got 3 days next week to get ready. And as long as you do the practice quiz, and then we'll pay attention when we go over it, it'll be really easy for you. Okay, just like we do all our tests and quizzes, right? They look exactly the same, right? Same thing with the exam, except the practice exam doesn't have multiple choice. It's just working it out. All right? Again, we'll discuss that more as we go. So, good job today, like always.